Yeah, now let us discuss some standard limits. Okay, these are very standard limits, very important points. So already in the standard limits I discussed two formulas, limit extending to a x to the power of n minus a power n by x minus a is equal to n into a power n minus 1. This is already I discussed. How you got? By L'Hopital rule also you can find this. And what you have learned, one more, limit extending to a x power m minus a power m by x power n minus a power n is equal to m by n a power m minus n you have learned. These are the two properties you learned. Now third property is limit extending to 0 sin x by x. Limit extending to 0 sin x by x is how much? See here, if I substitute limit in this, sin 0 by 0, sin 0 is 0, 0 by 0, 0 by 0 form you got. So whenever you get 0 by 0 form, we can use L'Hopital rule. What is L'Hopital rule says? Limit extending to 0. See, L'Hopital rule is what says, I'll tell you. Limit extending to a, if we have f of x by g of x, L'Hopital rule applicable. Suppose at this case, whenever you get 0 by 0 form or infinity by infinity form, whenever you get 0 by 0, infinity by infinity form, L'Hopital rule will be applicable. What L'Hopital rule says? Limit extending to a f dash of x by limit extending to a g dash of x. Means you have to differentiate the numerator separate, denominator separate, then you have to substitute the limit. Suppose after differentiation also, when you are substituting limit, you get 0. Suppose you get 0 by again form, then again you have to do double differentiation, then you have to do. Like that you have to follow it. For example, you have limit, suppose you have limit extending to a, limit extending to 0, I'll take limit extending to 0, I'll take this. And I write here x cube minus 4x square plus 2x divided by, for example, just I am taking example. So x square plus 4x, you have like this. Okay. Now if I differentiate, what I get here, if I substitute here, I get 0 by 0 form. If I differentiate, what do I get here? Limit extending to 0. I differentiate on the top, 3x square minus 8x I'll get. Okay, and if I differentiate denominator, what I get here? X square differentiation is 2x plus 4 I get. If I substitute limit again, I get again 0 by 0 form. So what I do, again I will differentiate. So limit extending to 0, I'll differentiate this again. If I differentiate this, 6x I'll get. This is I'll get 6x and minus 8 I'll get. And if I differentiate here, I get 2 here I'll get. Limit extending to 0, 2 I'll get. So I can substitute now limit, because here not making any 0 by 0 form. Then I can substitute the limit in this. If I substitute the means 2 times I did differentiation. Now I substitute the limit. If I substitute here, I get minus 8 by 2, that I will get minus 4. So L'Hopital rule we will apply like this. Okay, and we will separate till that indeterminate form reduces, removed, till that we will do that. Okay, we can do differentiation form. L'Hopital rule we can till apply 1 time, 2 time, 3 times also. But almost 1 time answers will get. Rare cases you get 2 times and 3 times. Okay, now look at here. So I want to find this one. So actually geometrically proof is very big. I am not going for geometrical proof right now. Here also there is a there is another proof is there, but geometrical another proof I did not explain. I explained by L'Hopital rule. If you want, I can explain that also. I will send the proofs in your group. You can watch it and learn it. Okay, if you want these proofs, I will share in the group. You can watch it geometrically. If you want proof, you can ask me in the group. I will share. So here I will get limit extends to 0. Sin x. So sin x differentiation I do. Okay, differentiation of sin x. What is the differentiation of sin x? Cos x. Now differentiation of x. What is the differentiation of x? That is 1. Now I will substitute in this. Suppose if I substitute cos 0, I will get cos 0 by how much I get 1. So remember that this property is limit extending to 0 sin x by x is equal to 1. This is the golden formula. Limit extending to 0 sin x by x is 1. So this is the third standard fundamental rule. This is the first one, this is the second one, this is the third one. So this is trigonometric, or we can say trigonometric limits. Okay, and the fourth one is limit extending to 0 tan x by x. This is also 1. Okay, here one more thing, this reciprocal limit extending to 0 x by sin x. This is also 1. Another one, limit extending to 0 x by tan x. X by tan x. This is also 1. Okay, here let's discuss the fourth point. Limit extending to 0 when you have tan x by x. Now you know differentiation of tan x. What is the differentiation of tan x? Sec square x. Sec square x by differentiation of x is how much? Differentiation of x is 1. Now if you substitute limit here 0, sec square 0 I get 1. Sec 0. Sec 0 is how much? 1. 1 square is 1. So answer is how much? 1 you will get. Okay. Sec is the reciprocal of whom? Cos. Cos 0 is how much? 1. So sec 0 also 1. Right. So this is what you get. So there is one rule here. Limit extend to a sin x by x is 1, and reciprocal also same thing, you can apply L'Hopital rule. You get here 1 by cos x and 1 by cos 0, that is 1 by 1 you will get. So however you are going to get